Hello, welcome to today's class. So in today's class, we are going to be talking about rate of flow or discharge. Basically, when fluids flow through pipe, we simply say that the fluid is actually flowing through a certain intensity or simply called discharge. So rate of flow is simply the intensity or the amount of which fluid flows through a given pipe. For instance, if I have a pipe and I have fluid flowing through this pipe, okay, let's call this section 1 of the pipe, and let's call this section 2 of the pipe. So this is simply the inlet, okay, and this is simply the outlet of the fluid flow through this given pipe. So the intensity in which this fluid flows through this pipe within a given time is simply called the rate of flow, and it can be expressed mathematically as simply the area of the pipe multiplying by the speed of flow of the fluid. So simply discharge or rate of flow, discharge is symbolized by Q is simply given as area of pipe, okay, area of pipe multiplied by the speed of flow or velocity of flow, okay, the speed of flow of the fluid. And this simply implies that discharge Q is simply equal to area times velocity, and the unit is measured in meter cube per second, okay. Now the basic law which governs the rate of flow through a pipe or simply discharge is simply called the continuity equation. Is called the continuity equation. Okay. So the continuity equation is simply the basic equation that governs the rate of flow of fluid through a pipe. And the equation simply states that the discharge at the inlet of every pipe is equal to the discharge at the outlet of the pipe. That's simply the continuity equation. The discharge at the inlet of the pipe is equal to the discharge at the outlet of the pipe. So if we have a pipe in this manner, okay, having an inlet and an outlet, the law is simply saying that the discharge at the inlet, simply called this Q1, must be equal to the discharge at the outlet, simply called this Q2, for the flow to be continuous. And therefore, this implies that Q1 is equal to Q2, where of course we know that Q1 simply means the area at section 1 multiplied by velocity at section 1. So we can simply rewrite this equation as simply, since this charge is area times velocity, it means Q1 is simply area at section 1 multiplied by velocity at section 1, and that is equal to the area at section 2 multiplied by velocity at section 2. So this is simply what the continuity equation. The rate of flow at one portion of the pipe must be equal to the rate of flow at the other portion of the pipe for the flow to be actually what? Continuous. Okay, so we simply have that. So that is basically all that governs rate of flow or discharge through a pipe. So let's start with a simple problem and see how we can apply this given equation. All right, so to back up our explanation on rate of flow or discharge, let's consider this question on the board. The question says that the diameter of a pipe at section 1, and 2, are 200 millimeters and 300 millimeters respectively. If the velocity of water flowing through the pipe at section 1 is 4 meters per second, question says 1. Find the discharge through the pipe. 2. Find the velocity of the pipe at section 2. So let us draw the pipe. We are given that a pipe at section 1 and at section 2, of course, has a diameter. So call this section 1 of the pipe, and call this section 2 of the pipe. And we are given diameter at this section. Diameter of the pipe at this section was simply given as 200 millimeter. That's section 1, 200 millimeter. And diameter at section 2 was given as 300 millimeter. Okay, so this is 300 millimeter. And the speed of flow, okay, the question says if the speed of flow at section 1 is 4 meters per second, so this is section 1, so simply call this V1 is simply 4 meters per second. Question is asking us to find the discharge through the pipe and also velocity at section 2. V2 is also unknown. V2 is simply unknown. So we have this. So first of all, let's convert the values of these diameters to be in grand units. This is diameter at the inlet, which is D1. This is diameter at the outlet, which is D2 at section 2. Okay, so D1 is 200 millimeter. 200 millimeters. So we'll simply convert this to meters. It becomes 200 multiplying by 10 to the power of minus 3 in meters. And this will give us approximately 0.2 in meters. Okay, next is diameter of the outlet. D2 was given as 300 millimeters. Okay, converting to meters, it becomes 300 by 10 to the power of minus 3 in meters, and this will give us approximately 0.3 in meters. So we have this. Now the first question says we should find the discharge through the pipe. Of course, we know that discharge Q is simply equal to area at section 1. This becomes the discharge at section 1 now. Area at section 1 times velocity at section 1. So we need to obtain the area at section 1, not forgetting that area at section 1 is simply equal to pi all over 4 times diameter at section 1 all squared. This is the formula to find area of a pipe when diameter is given. So we have pi all over 4 times diameter at section 1 all squared. Therefore, area at section 1, A1 is equal to pi is a constant, 3.142 times diameter at section 1 was given as 0.2. So we simply have 0.2 all squared divided by 4. So this is equal to, all right, so 0.2 squared multiplied by 3.142 gives us 0.1238 all over 4. So this implies that the area at section 1 is now equal to 0.12368 divided by 4. That gives us 0.03142 in meters squared. So having found the area at section 1, we can now find the discharge at that section. Therefore, discharge, which is Q1, is now equal to, we said this area at section 1 multiplied by velocity at section 1. And therefore, Q1 is equal to area at section 1. We have this to be 0.03142 multiplied velocity at section 1 was given as 4 meters per second. V1 was given as 4 meters per second. Okay, so this simply implies that discharge at section 1 is now equal to 0.03142 multiplied by 4. That gives us 0.12568 meter cube per second. So this becomes the discharge through the pipe. The next question says we should find the velocity of the pipe at section 2. Okay, so we have to obtain velocity at the pipe at this section. So we employ the continuity equation, not forgetting from continuity equation, okay, we have that discharge at section 1, Q1 is equal to discharge at section 2, which is simply Q2. But of course, Q2 now is now equal to, that's the discharge at section 2 is simply area of section 2 multiplied by velocity of section 2. So if this is Q2, it now means that we can rewrite this equation now as Q1 discharge at section 1 is equal to, in place of Q2, we have area at section 2 multiplied by velocity at section 2. So from here, we can simply make velocity subject. Velocity of the pipe at section 2 becomes Q1 or discharge at section 1 divided by area at section 2. That gives us Q1 all over A2. Already we know the value of Q1. All we need to do now is to find what? Obtain the value of the area at section 2. Take these two divisions and obtain the velocity at section 2. Let's do that over here. All right, so we obtain area at section 2. Area A2 is still the same thing as pi times diameter at section 2 all squared all over 4. And this is equal to pi is a constant value, remains 3.142 multiplied by diameter at section 2 was given as 0.3 meters. So we have 0.3 all squared divided by 4. This simply implies that the area of the pipe at section 2 is now equal to 3.142 multiplied 0.3 squared. This gives us 0.28278 all over 4, and that's simply equal to 0.28278 divided by 4. That gives us 0.070695 meters squared. So this becomes the area of portion 2. Therefore, velocity of the pipe at section 2 is simply equal to, we obtain that equation over there as simply discharge at section 1 all over area at section 2. This is equal to discharge at section 1 gave us, that gave us 0.12568. Okay, so we have 0.12568 all over the area of the pipe at section 2, which is 0.070695. So this implies that the speed of the pipe at section 2 is simply equal to 0.12568 divided 0.070695. So that gives us 1.78 meters per second. Okay, so that becomes the velocity of the pipe at section 2. So it can be as easy as this. Just know that from the continuity equation, discharge of the pipe at section 1 equals discharge at section 2. You know the formula for your discharge: area times velocity. Apply those principles together, of course, you can be able to find anything on rate of flow. Okay guys, so I'll pause the video here. In the next video, I'll do a different sample problems, involving more than one pipe connected together. I will see you in that video. Please, if you're new to the channel, please don't forget to hit the subscribe button, and of course share your thoughts in the comment section. Share this channel to your friends for more subscribers. I will see you in the next videos. Thanks and cheers.